Okay, let's start. Good morning. Yeah, so as usual, so the first announcement is this is the final reminder. Send me your profile photo. I think I have uploaded some. Yeah. So if your name is not appearing, please let me know. Yeah, and you see, there are some who have not sent. I hope this is not so difficult task, right? Yeah. Okay, so please. Now, before we proceed, let me take attendance. On, yeah, Innocent. Oh, he's not here. Somewhere. You're here. Lawrence. Yeah. Francis. Yeah. Paul. Okay. Collins. Oh yeah. You are solid propulsion, right? Yeah. Okay. Live. Yep. Jones. Ruth. Sapa is not here. Oh, okay, on the way. On the way. Edwin. All right. Edwin. Yeah. Okay. Red. Yeah. Jen. Yeah. Shaba. Oh, I skipped the page. Bruce. Edwin. Yeah. Anybody who you're oh, you are Denzel. Which one? Builder. Okay. On the Denzel. All right. So let me proceed. Today, can I request? Okay, which one? Anybody who wants to present first? Oh, okay. Go ahead. Sorry, propulsion. Yeah. Yeah, go ahead.
So last week we were designing the stuff. I went to the supply of the notes and he said that the way it's speaking, like many of the notes are being conducted in stuff of the notes. So we went with this approach in that approach, but we need a long activity. Yeah, because and then those constraints they are protected. Ensure that the test give the full stage, the accidents, and then I was considering between bicarbonate and the carbonate. The membership becomes like that, and also it will be similar to their inward. What else? The weight we estimated to be about 14 kg, but we can do some sustainability. So that we can carry 10 kg, which is where it's around 20 kg. Because till for the question, we want to start data is super street and finishing the but it's not going to be yes. And materials, we have guidance to be but now we need that convenience to be there.
Okay, so for the material process, remember you went to the town, right? So did you get any quotation?
These materials, we will see
Okay.
And
Right. Yeah. So please prepare the quotation. Just wondering, what is the material for this glue or wing? What is the material? Is it the steel or steel? Mhm. Maybe you need to think about where to place the controller. Are there any particular location for the controller? Far away. Okay. So I strongly encourage you to create a cover for your controller because we have been using bare circuit, which is actually it is weak in terms of dust, in terms of water, rain. Yeah. So please also consider.
This level of supply, the same as 15,000, yes, 15% tax. Yeah, the capacity is
So do you also require the amplifier like HX711? So we can basically use the same as we have been using.
We started to we had service to find a way correcting the model. Yes. So we found from the site from that I was using the line to target it. So that's we use a liner to best remove the liner just so that it will be much more easier than sticking the model and to be able to increase the so we can do the part more with the running that can split apart and we split apart the case and so the same just
Okay. So this blue cylinder is PVC.
Created one team for aluminum testing, but then found one from when I tested, but we found that the was small, the bigger than what we needed, and we are still looking for the team for which we can look. We have not yet found stick and that's she will
Have you already purchased?
Yeah, we have found that because showing the and we found that Naka used 61 and and 2775 we see we can look for any of those materials because have good properties for making
So I hope you remember. I requested you're going to. Okay, I talked with Faith that I requested you create a table to summarize the strengths or advantage and disadvantage of each material, like aluminum, 60, 61, 70, 75, and steel, mild steel standards. Have you done that? Maybe can you show that? Oh, so I remember. So this steel and mild steel and stainless. Were you talking about the casing of the motor? And also, okay. I see. Okay. Okay. Yes, yes. The reason why I'm insisting that this is the information sharing purpose, because the next team is coming to join you, so that you have to transfer your discussion. Yeah. Yes. Mhm. So you want to buy something from case metal? Okay. Yeah. And again, so I was a bit surprised. You have already purchased aluminum. So every time you make purchase, you have to send me the item and price. Okay. Yeah. So I'm saying that instead, okay, the purchase receipt is okay. I confirm, but this is a mixture of this item is bought from this one, this item is bought from this one, and purchase date is always different. So what I'm insisting is, so before making purchase, maybe on the day or day before, you send me this item you're going to buy, and this is how much. So that because what I should do, I'm in charge of accounting. Accounting means I should track, how much is spent in which day. So every day, basically, I have to check how much money is spent. So, and actually, the amount is limited. The amount which can be spent within a day. So that's why I'm strictly requesting you to let me know how much you're going to spend before you spend. And did you already upload your receipt? Okay. Yeah, go ahead.
We were supposed to prepare the proposal, but officially say that we need power sharing. So we will start testing the same community study, but plans assessment depends on what we just before. So we let's see as the more so there is this and then we can see the so
Okay. I need to tell you some important thing. Yeah, in terms of safety, there was incident one day. So the propulsion team were preparing the solid rocket motor. During the casting process, the fuel accidentally spilled off from the pan. The spill program touched the heating element of the heater, which caused the ignition of the product. So actually, this entire building was covered by smoke. So that's why we have replaced our coil heater with IH induction heater. So you're going to use induction heater, right? Yeah. So in that case, I think we can avoid this issue. But still, you have to be very careful. Okay. So that after this incident, we have agreed with the workshop manager. So we have to always inform either technicians or workshop manager when we are going to cast, okay, so that they are aware. Safety equipment, like what kind of? Mhm. No, you are the one who are going to prepare. Yes. Yes, yes. The airframe teams are already working on the fabrication using the resin chemicals, so they already purchased. Yeah. Okay, so I think that's it. Okay, do you need any letter, like a request letter for using the laboratory? Okay. Okay, in case you need, I can issue a letter, but you have to draft. I think that Paul is working on it, so he's also requesting to use the facility in the welding workshop. So this is a draft. So you can list your names and registration numbers, and you can change here to adapt which facility I want to use. Okay, I think I can share it to you. Let me install. Yeah. So in case you need any request letter for the facility, yeah, so that I can sign. Yeah. Okay, thank you very much. I need to check. Mhm. Okay, I think you need to update the Gantt chart. Do you have, where is your Gantt chart? Did you upload it on? Yeah. Yeah. No. No. Yeah, anyway, because we almost completing the half of the duration of the period. So yes, so especially, so you are currently preparing a small scale model, right? So it's a single grain. Yeah, but the dimension is the same. Okay. So at the end of the day, you're going to put 4 grains. So maybe you can think about by when you're going to complete the testing of the single grain, double grains, triple grains, and full grains. Yeah. All right. Any progress for the electronics? So you mentioned this one, what? Load cell. Did you already design the controller? Mhm. Uh-huh. Okay, so don't start from scratch. There is a GitHub repo for the test time. Have you already checked? it might be here or somewhere else. I think you need to talk to Felix or Washington, the former members, about the location of the code. Then check it out, and if it is usable, please just use it. You don't need to waste your time for making it from scratch. Yeah. And if there is some function missing, you can add. Yeah. And also, I requested. When we started this internship, one of the solid propulsion task, I think I can open it again. I hope you still remember. So you're supposed to include this may not be the one. Yeah. So improvement of static test stand for immediate static test. Do you remember what it means? Yeah. So in terms of setting up the static test stand, so maybe you have to. I think it would be best if we can plug and play. Yeah. So we just bring the test down and we insert these cables and connect to the power. Then we can start the test. So instead of wasting much time for calibration, so on. And did I mention? So yeah, real-time static test analysis. So what we have done so far, so we collected the data. We have been keeping the data on the database, and we analyze after the static test. Maybe IT after we came back. But if we can analyze real time, or maybe just after the static test on site, it will be the best. Yeah. So, and one of the funny things is that actually one of our interests is the maximum thrust generated. And since it was reported on the database or maybe on the CSV, so what we did is to check the maximum thrust. We open the Excel and we just scroll to find out the maximum thrust, yeah, which is not so efficient. So maybe you can just write one single code or two codes, two lines code to detect the maximum thrust. Okay, fine. Any questions to solid propulsion team? No? Okay, thank you very much. So next, who's next? Who wants to be the next? Right, okay, go ahead. So liquid propulsion team, very good. GitHub. Okay, seems to be week 6.
Yes. still they are going to sense the progress of medicines as well as the difference for the doctors. So some plastic medicine we are able to acquire some components to use the making which will operate the house and control the advanced sensors. And the other sensors have been used to some for the implementations. For example, it's very implementation between SE and Mega, Mega. We design the circuitry where we have a slave microcontroller which is purely for taking the sensor data from the regular sensor to the analog sensors, which is there for the same use, then to give the data from the screen, which is the communication. The user, the database, so I'm able to link the alternative method to slave information. And this you to connect to this the external database using database to the database that we use. Yes, we also the sensor parts in order to do a evaluation of the experiences. We use a very similar, almost the same code which the previous things are used. Felix and whatever is used. And we have done a little innovation and written also to maintain and focus on this those are the developments who are going to the standard that is it's a level it's going to and how they is communicating with the clouds and the research kind modeling of this space up we are design a space up which fitted with the combustion chamber we have. But we notice some issues not only on the fuel of the cooler, so the cooler to the fuel, and you have then a design of the spacer which has parts in the cooler to the fuel. We have done a testing stand modification. The test stand which we have was now 20 years and the picture 20 years the two cylinders in the back. So from the picture there are two wide cylinders and two narrow cylinders. So the two narrow cylinders are for the gas which we have the nitrogen here. And for the person listening for the fuel for ethanol, we have decided to use intern. And so here we have used two, and we come to the conclusion that I see two will be better for us to live with this one, which for now I see the water testing uses to pressurize water, to run it engaging, then quickly release it. And recently, the drilling system modeling for the balance situation between the characters and other composition. So this our character use. I usually come with one opening at the top, but we for our application we need one which has two openings, one for the nitrogen gas which will be pushing the fluid on the other one where the fluid or the liquid will be meeting, and we have identified passing the innovation and knowing the passing. Yes, and you see that definitely the request includes the request that is that was 15 bus. It's actually reaching for 10 bus. Però siamo tutti pensando che females sensors and outcome studio, which will inject these spots the PFC servicing and to not to implement on our system. Yes, and then for the specific we need you see how the things shapes the liquid. So we are looking at using dynamic balance and so the release come up with a code to control the balance fluctuation of the dynamic. Yes, and we are continuing the very system modeling with the dynamic exams. Confident production to the confident statics and the prototypes.
Okay. Thank you. Okay. So, what's your idea? When are you going to start the first block pressure test?
So, there was a component for the economic study. So, I'm trying to face actually those very negotiations for the looking for the standard parts in the market. For okay, there was another challenge we came up with. Actually, it became a bit difficult because using the boards to secure the control assembly, the boards and looking for one which matches the sensor specification is the challenge. So far, we've been looking for other solutions that can also use such as using a very to secure instead of a board securing something that is potentially. But until you actually come up with this one, now we are searching for the appropriate solutions. But if once we can find the appropriate boards, you can move on and the gradually can move on to the low pressure test. Of course, we wanted to use box, but we stopped that idea and decided to just choose the actuation of the singular.
It's an issue related to the hydraulic system. Is it covered in this GitHub issues?
I think
do you know which one? Yeah, I'm asking you the hydraulic system modeling. Where is it?
But it's something we would really be working on.
I'm asking, is it there or not there? Okay, so please include everything in the GitHub issue. So GitHub project or GitHub issues. Okay, for honestly speaking, I think project management is not going well under Wiki team. The reason is, as I said, maybe in the last week I mentioned that you should point out the entire task, and you should present, how far you have gone. Okay, so there is a forest. Forest is a collection of the trees, right? So the presentation must start from the entire picture of the forest. Yeah. But you see, if you start from one single tree, and maybe you discuss the next tree, the next tree, next tree, but we can't get the entire picture of the forest. Yeah. So because if I hear about something about the issue related to the hydraulic system, I think it's just focusing, from anywhere. Like, so I don't know the relationship between each trees, basically the each tasks. Okay. Maybe after this meeting, can we have a meeting with Wiki team to clarify all the tasks? So what I expect, so in the presentation, so ideally you have to present the remaining tasks. Okay. If there are too many, you can just summarize and categorize. But I want to see, can I add something? Maybe I can add new slides, like a remaining task. Yeah, so design of A, design of B, fabrication of A, fabrication of B. Yeah, and this is self design of A1 something. Yeah, A2, blah, blah, blah. So once you complete, you can just remove it so that we can understand how far you have achieved, okay, and what is remaining, so that we can estimate if it's feasible to complete your mission. If it's not feasible, we have to consider the way forward. Yeah? We have to change our plan. What we have to avoid is that maybe at the end of the presentation or at the end of the day, we just report we couldn't achieve. Yeah. So we have to always adjust our milestones, our work plan, task allocation. Yeah, because actually for me the information is very scarce, so I cannot judge or comment the how you are going to proceed. So yeah, let's have a meeting after this to be close. Yeah. Okay, so let me proceed. Yeah. You have a recovery. Oh, but anyway, you can always request me to have a meeting, like my airplane team is doing. If they can just ask me to have a brief meeting, like 10 minutes, then we can set the direction, then we go. Okay. So if you get lost, if you have any challenges, you don't have to be quiet. Okay. Just shout it out. So we quiet. Uh,
It's also we are supposed to do the injection process. That should be different. So for the hypertension test, the main goal of the test is just to ensure that we have written communication over against that's going to be. So as we mentioned last week, last week we had some challenging where we were only able to get opportunity to next design design. But for this time, we're able to find that it may not seem to be enough because we start to communicate. But the hope is that even though we communicated efficiently after 7 years, the society of the world was very strong, it was pretty bad. So it means that the problem for me was that we were actually have to kilometers and also realize that the machine the setting of the antenna where you can adjust the maximum distance that it can achieve. Because it is initially set to find it, so we think that it measuring that it's happening our communication is.
So the theoretical range is 5 kilometers. Okay. And you mentioned the improvement. How can you extend?
So the dashboard for configuring the antenna, whereby you can adjust the maximum distance. So it will, when we look at it, we can
So that's why it can communicate up to 500 volts.
Yes, something that we
So can you just increase it.
Yeah, there's an option for adjustment.
Have you done it?
When we relate it at the end, we will have almost following the
Sounds it's very easy. Just why don't
you
you
want to finish it?
please do it.
Also, we were able to simulate the design which is the format of the dashboard, the dashboard, people who are in the dashboard. People initially use them and what to do with this different. The other stuff that we did last week was supposed to be the antenna design. So the antenna design is really reliant on the access and the communication. So that's a good way to push the PC. The antenna design. The other thing we're looking at is the research program. Considering the communication that we're given by the potential or to consider the material which we're using, so that's one of the for us to be done with you. Also, this becomes because we are something for and it will do that for us, which is just many versions of us. We are one.
Okay, so what's your decision?
So like this question the voice to my
Okay. Yesterday, Edwin mentioned you're going to use the aluminum.
For the system,
Yeah.
the one we have is very heavy at the moment.
Uh-huh.
But other material, I don't know it's really, but it is still aluminum.
Uh-huh.
It's lifetime, it's strong.
Okay.
And then we went for the machine. Last week we bought the boats. I told you that they are made of stainless steel, which is hard for they are passing for mild steel doors, which are easier to so the boats are the ones that will contain the ozone powder that was
Okay. Last week, Dr. Mushiri even mentioned that you can still use plastic if you can insulate the heat. Do you even know? But I use this using metal.
you can work with more than compare
Oh, okay. Yeah, yeah. Maybe I understand. You can always compare, but if there is apparent advantages, you don't need to make more. You can just give up because this is a design decision. Yeah. Well. Yeah, for me, the plastic is much better because there is no reason to abandon this option. I thought because it's much lighter, it's much manufacturable and machinable. You know. Have you also started working on aluminum?
Yes.
I think that you can just change the direction with the plastic. So yeah, it's much faster. Yeah.
So another thing that we're working on is to do the so the main goal is to incorporate using tracking of the nodes. So on the dashboard, initially only had the live stream notification but now we have incorporated real-time tracking of the rockets by using Mapbox. So we're being able to successfully read data. We just entered the script where we have the ability to the most
Oh, this is offline, right? Okay. All right. I think that's an improvement because the last time we had to connect. Is it online, offline? Do you know what is online offline? Yeah. Do you always need to connect to the internet, or can it be used without internet? Yeah, please help. Without internet. Okay, that's good. That's great. Right.
So for the next objective, please not to schedule the organization because we have to put priority on the organization task before the university or pushed agenda to be also there are around 20 have begun and the data will be person down to the we also be doing the chances depending on the since we want what it has to me and vice has to the plastic instead that to be one of the things that we
Yeah. Another concern is this boards will be ejected with high speed. So I want to avoid any injury. So maybe we can start much safer material like a plastic. Then if it works or if it doesn't work, we can consider the other method.
So some of the challenges we especially this year with the flashing of 4G devices, whereby we're facing this error. We have faced this error before, but we don't have the right solution because I think just working on the so if probably the team has any issue that you can do to contact this challenge.
Oh. Okay. How did you find the solution? I mean, what's the solution?
We don't have an solution because before we facing the challenge, we just don't have anything. But we have been given information that we train flash data around these things.
Okay. Yeah. Right. One important aspect is missing. Did you complete internal memory storage? Have you done? Oh, because you see, one of your major mission is to implement the onboard data logging, and you're saying it's already done. Is it SD card? Flash.
Using flash recording, at least when we were in sensitive intent, but using the which flash recording.
Okay.
We will continuously do this. For now, it is done. But once the votes are here, we will also do that just before launch.
I see.
Sure that it
Oh, so you mentioned once the vote is done, so you're making in-house or you are outsourcing?
We got a place within Westland.
Restaurant.
Yes, they do.
Yeah, assembly. Really?
Yes.
PCB fabrication and assembly. Is it gearbox or no?
It's
Can you share the information? I'm very curious.
we have some goods that it has done locally and right where that.
Okay. Right. So maybe ask question for Jim. For the flash memory, are you only writing the data? Are you still reading the data?
So we are able to
Read and write. But for your application or for the controller, applied controller, do you need to read?
we read it after, but was right and then.
Okay. I got it. So the writing, I want to make sure if you if you have if it's a flash memory, the writing frequency, is it enough for your application?
It has just 300,000 strands. So it's enough. It's showing for a very busy should be writing.
So let's say
300,000 strands.
300,000. How many kilohertz or megahertz? Maybe, yeah, you can, yeah. Yes. Okay. Well, ejection test. When do you conduct the ejection test?
So I hope George sent me so he has me to powder tomorrow on.
Okay.
So it dries to him. Then we just put them on Friday.
Okay. Just make sure. I think you have to start from small amounts. Let me show you. Where is it? This is not here. Oh. Yeah, you see, I think it's too strong. Yeah. So if you use the same amount as M2, I think it will be a bit dangerous. Yeah. So that's why I'm insisting to use plastic instead of aluminum. It will, the blade will run. So start from small amount, then increase. All right. So I think so I hope it will be easily applied to up to 2 kilometer or 5 kilometer even. Any questions to recovery team? Comments? Yes, please.
Challenge. There was also the challenge of making
Meditation, this one? It is a kernel panic or something because it's so it's related to the operating system, the RPOS.
So we had to do something. This since the internet connection
And so it is related to the internet environment. This is saying,
it's not that the digital error is arising from it's a internet connection.
oh,
I'm saying that we are not able to research on this.
I see. It's whole connection. Is it working? The Ethernet, the wire cable. Is it working?
Yes.
Okay. Do you have the Ethernet ports on your laptop? You don't have cable. Then okay, we can get cables. Okay, look for the cables. The request approaches, and I have kind of a repeater hub, so we can just insert. From one connection, you can multiplex. Oh, still there is an issue. Let me talk to ICT. Think, okay, that's my task. Okay. Right, thank you, recovery team. So the final team will be Airplane, who is presenting. That's it. Oh, Discord. Let me check. Right. Go ahead.
So, about next week or objectives. This week we wanted to start with the fabrication of fiberglass. We noted that there was some resin and fiberglass left from the two. So we wanted to start with that. We get familiarized with fabrication of fiberglass before we start our fabrication. Yes, the next objective was the revision of the rockets. We wanted to optimize the rockets. This week we focused on stability, then and we started a bit on the strength analysis of aluminium, but we also continue with fiberglass and also thermal analysis. So we do a safety test, then safety, and then we also design a fin aluminum jig so that we could attach the main body. So those were the 6 objectives. And next week objectives were procurement of the fiberglass and aluminum materials for this project, and also to design the launch pad, also from some issues with the designs of the launch pad. So, the fabrication of fiberglass, we contacted our local expert Paul. He helped us a bit in the fabrication of fiberglass because he was familiar with the materials. And also from there we found a lot, we learned a lot, and we went in, and from then we learned how to protect ourselves, how to apply the resin, how to spray application method, and realized from the fabrication we required a brush because initially we were on the next slide. On the first attempt, we were just pouring the resin on top of the fiberglass, but we realized the spread was not uniform, so we required a brush so that we perform a uniform spread on the resin. That will improve the fineness of the material. Because as you apply that, parts of it will have too much resin and other the resin will be too small, and then bring a bubbling effect, and then the surface will be smooth. So we required a brush, so we in the process of procuring it. So for the parameters, we looked into the rockets. We ran several simulations of the rockets of our rockets. This week we decided to tackle the problem of stability of the ocean and the flight path. So the next slide is the first. This is the first simulation. The first simulation is the 5 division model we started with. As you can see, the stability rises up to a certain height, and then the ships begin to stabilize the rockets up to the apogee, and then it falls drastically, and because it is now falling, so it will not be stable as it falls. So we wanted to achieve a stability margin of 1 to 2, but we realized there was during the flight path, the most optimum was between 2 and 2.5. That was the sweet spot. But during the initial flight path, it was very stable. But the problem with this is that off the launch run on this side, you can see that of the launch run, the stability is 0.06, and then it begins to stabilize at around 15 meters. So we wanted to reduce it a bit. So we refined it. The next slide is.
Okay, I have an issue. I didn't understand this graph, and so maybe I need to ask you. So, but okay, for the graph, yeah, for the scientific graph, you have to add the axis. So this one is it the time?
Altitude.
Altitude.
Yeah.
Altitude. Okay. So you have to write here altitude and bracket meter or kilometer. I think it's meter, right?
Meters.
Meters. Okay. Then for this one, this is stability. So stability doesn't have, it's a dimensionless, right?
It's calibers.
Oh, calibers. Okay. Yeah. So you can just describe it here. Now I want to understand. So the as altitude increases, the stability. Okay, but for zero, the stability margin is
because the sensors and the meters and the data set is so large, you cannot find the exact point in this stability. So the zero sheet just rate is at 0, and then I think stability is on the left side.
this is a static stability, right? Like caliber. So the in your airframe design, what is the static margin?
The margin, the best margin is between 1 to 2.
Come again, the
1 to 2 of the
1 to 2.
calibers, 22 calibers.
1 to 2 means a 1.22.
Between 1 and 2.
1 and 2. Oh, between 1 and 2. Okay, because for the open rockets, I can open it. You're supposed to see the static margin. Here, right? So I'm asking you about this value.
This value is only at mark 4.3. So as the through the first part, it's very challenging because the weight is reducing and the velocity is increasing.
Yes.
So we have to make it through the flight path when the propellant is full and when it's empty. So we have to make it through the flight path as the velocity and the weight reduces. The velocity process and the weight reduces. This one you find at mark 0.3.
Is it your design? Oh, this is not your design. Yeah. So I don't know where. Oh, anyway, yeah, it's okay. So let's move back. So okay, so your conclusion is. Yeah, I just wanted to know from this graph, you want to say.
We want to check whether the rocket will be stable throughout the flight path. Because one thing is the static stability that the rocket shows, that it's a specific instant at Mach 0.3 and at a given weight. But as the rocket climbs throughout the altitude, the weight changes and then the COG and the CP changes. So if it's not stable, you have an instance where the rocket rises up nicely, and then this for certain altitude and topples over because it's not stable. So we want to ensure that throughout the flight path, the rocket remains stable. We checked that for most of the flights that is off the road, the rocket is stable because although the recommended stability is between 1 and 2, we read up on some literature and found that as long as the stability margin is below 5 calibers, the rocket is stable enough to go on to its jump as it rises up.
But how about this area from 0 to 1?
From 0 to 1.
This is unstable.
Yeah, it is unstable. Most of it is on the launch road. The rocket has not yet reached a velocity where the things are providing enough.
Oh, okay. So maybe getting so.
So at 15 meters, it's only to become stable. So we wanted to reduce that height to between up to like 7 meters.
Oh, okay.
So that off the launch road, it is stable.
Could you write such an explanation in this slide?
Yeah. So the second one, which we optimized it further. It became more stable to grow the frame, but off the launch road, the stability is negative. So if off the launch road, it becomes very unstable.
Yeah,
so,
very unstable.
Yeah. So what we decided is we increased the length of the launch road so that up to 3 meters, so that it holds it as it will. So because we saw that up to like 10 meters, the stability margin of 0.5 is not that bad. So if you launch off at 0.5, it will be good for us, and it will launch off the road when it's stable. So the next slide is the final one.
Oh, by the way, the parameters, what is the difference in the parameters for this one and this one? What kind of parameters did you change?
The fin side.
Oh, okay. Then you have to also describe the parameters used in that slide. I think at the end of the day, I think you're going to make a presentation, and I think I asked you to mention this optimization. And in that slide, I encourage you to include such information like the parameters and maybe the brief, or maybe you can point out here. So that this is a kind of a threshold, so that rockets will be stabilized. Yes. So.
So we build up around it further. Yes, and now when we increase the launch of the height up to 3 meters, the stability was nice as it reduced of the launch rate is 0.5 up to like 8 meters. 0.8 is a good margin, it's stable.
Okay.
So the launch rate will be, that's how I had to design the launch rate compared with other parameters. So the new launch pad will have a launch rate of 3 meters.
Okay. I think you have, okay, that's understood. I think, but when there is a kind of a trade-off, like if you increase the length of the relay, launch radar, there will be possibility of displacement. You see at the end. So the very slight error of the inclination here will affect because it's r times theta, right? R times theta. It's r length. So there will be a possibility of the huge error. Meaning, if you are going to increase the weight, you have to fix it really tight, at the bottom. Yeah. But I understand.
So onto the next agenda, we will deal with the fin aluminum chip. Yes. So what we have to achieve is a portable chip that could be placed anywhere, and at the base we decided that the base will be placed anywhere. So the next slide. So on the next slide, it will have all of this, so it can be placed on a table or on the floor, as long as the base is flat surface. So the materials we used were so this component would be made of carbon, that would be made of wood. So this is where this will be the structure that puts the rockets in place. The base can be wooden or any other base as long as it's flat. And then the metal chip there will be made of aluminum. We consider steel, but it will be very heavy. So the tube rods there are made of steel or made of aluminum. And then the circular tube there with the protrusion now is that's where the rocket will be placed, as it will be attached. And then on top there are two slots on top of the tube. That's where an elastic cord will be placed that will hold the rocket in place as you align it to the jig. So calculated the weight of the components. So they are standing in the wooden, and then it goes and adds from the volume all in fusion. And then from the volume and the quantity and the density, the weight of the material was 6.1 kilograms. And the support height is 5 millimeters. And 6 centimeters, so it's not a huge structure. The width will be 28. And then the width was large that it could accommodate rockets of various sizes. So if I fall down a bigger size, they can also use this structure. And then the wooden frames, they are not fixed in place. They are both there, so you can increase or reduce the height depending on the height of the rocket. So this is basically the scenario. Okay. So what we are looking into is the optimization of the framework frame. We have had an important idea of it, so we have to refine it and make it perfect. And then the design of the launch pad. And then we wanted to make adjustment of the unit because of the printing it. We found that the page back is too big for the slot where so we have to make some adjustments. That will be the things.
Okay.
So these are the things the organics there.
Okay, so you ended up 3D printing.
So after the printing instance, we got it.
Okay.
So the six goals are to the plans. So we optimization will now looking into the structural and thermal. So through the system, but if the structure can expand the loads and they keep generated, it's the not the last part and they are very stable.
Okay. All right. That's okay. Yeah. Yes, the another comment is fabrication. So let's see, because okay, we are going to order some materials for fiberglass today. Oh, just let you know. So you are able to go this afternoon for pick up items. Yes, aluminum sheet and fiberglass. For the aluminum sheet, are you going to also design a jig like this for rowing?
It's a different thing.
Yeah, it's a different jig, but yeah.
I think we do the one in the focus in the Nakuja stage.
Uh-huh.
Seems simple enough.
Yes. So please include your task. Maybe I don't know if you're going to do it next week or the following week, but please insert this task as well. Okay. Yeah, we will enjoy it. Thank you very much. Any questions, comments to your friend? Okay, thank you. Maybe I think that's all for this meeting. But I want to update the description on our website. So I want to update, describe the specification of rocket objectives and some components. So I will consult the team leaders about, okay, I want to show the current progress, like your simulation, like your 3D CAD design, yeah, your activities. So, yes. And yes, Jeff created this kind of job description. So I'm going to also upload it on our website. So there is a kind of a job description for each team leaders. Yeah. Maybe you can have a look at it later. I'm going to also share this one. This is not only for internship, but also for the Nakuja entire project. Other information. Oh, yeah, and I appreciate mainly the recovery teams working on posting the articles. It's recommended. Yeah, it's commended. Thank you. Other things. Oh, by the way, there is interesting information. I think some of you have met the professors visiting us from KU, from UON, Actually, the JQuad is preparing to set up a new department, aerospace engineering, for free from September. So the first intake will be done in September this year, hopefully. I heard that there will be 15 students. The capacity is 15 maximum, and so they are currently under the review for curriculum. So it depends on the situation, but there will be possibility of having such a new department. So I hope. I think if it starts, I think I will invite you for speaking something about Nakuja activities to encourage the new students. Yeah, that's a good news, right?
Yes.
Nation. Yeah, I think that's all for this week. Okay, maybe if you have any friends, your junior friends, you can just encourage them to apply for the aerospace engineering. Yeah. Fine. So thank you very much, and see you next week.